Today's video is sponsored by Destiny Solutions. Tools, test, safety, construction, and fiber optic equipment at www.destinysolutions.us. The part that the cable's geometry has to play in determining the impedance of the system. And each of the individual components is critically important, and they're tuned and manufactured to be nominally 75 ohm impedance. But when you think about the cable networks as a whole, you can take and start as small as your house. Most people have multiple outlets in their house, myself included. And when you go start to add up the sum total of the individual components that go into just your drop system, if you think about it, you start at the tap, you have an F connector and then a segment of cable that goes to another F connector and then a ground block and another F connector, another segment of cable that goes to a splitter. If you count up the sum total of all of those parts, there's a lot, and they all need to be, excuse me, impedance matched nominally about 75 ohms. And if one of them is damaged, through the environmentals or other things that we've already talked about, then the whole system is impacted. So for all the techs that are out there listening, you know as well as anybody the impact that one connector in one outlet in one house can impact potentially hundreds of people from a performance standpoint.
The entire fiber node, basically, it'll impact every subscriber on that node. It's devastating that one subscriber can impact 100 or more subscribers.
It is. But that's also the beauty of the network, right? Is that we can service hundreds of subscribers in a service group, and still offer the speeds and services that they want. But you're right, the potential exists that one
Correct.
connector and one premise can affect a lot of people. So impedance is really important. The geography or the shape of the cable is important. I think you did an article one time talking about the shape of the cable and the impact that you can have with a staple gun, just changing the shape of a piece of Series 6 drop cable and
Correct.
create a really frequency specific impedance mismatch. So there's lots of symptoms out there where we can identify that we have impedance mismatches, and they happen organically. If you think about the thousands of interconnected components in any node or any network of any size, any hardline pin fitting that's connected to a passive device, there's multiple opportunities at every installation point to create an impedance mismatch that can then manifest itself as, these pre-equalization coefficients, or as standing waves, or as suckouts, or as other things. So impedance is really, really important. I tell techs all the time, and I do it myself, just visibly and observe the network that you're working on. Because if it looks wrong, it probably is. Whether it's a kink in a hardline cable on the pole, that could be from an old drip loop that wasn't formed quite right, and over time you'll see the kink that's probably, if it's not already a radial crack or a ring crack, going to become one. So just the physical geometry of the cable itself is important to maintaining 75 ohm impedance. The rest of it's you guys did a series with Ron on the chemistry of cable and corrosion, which was a great article that he wrote years ago too. And those types of things, they can be really, really frustrating because you can't physically see that corrosion, but it's causing you a problem and you can see the symptoms of it.
Yeah, and those are the problems, I think, where we turn to proactive network maintenance, because problems you can't see are the most difficult ones to solve. And I think that's where P&M can come in really. So P&M kind of helps find, we get this impedance mismatches, loose connectors, corrosion, all of these types of things. That's where P&M, we've talked about, is that a reactive tool? Is it a proactive tool? It started off being a very something that we pushed really proactively. However, it is an extraordinarily helpful reactive tool, because if you're out there trying to solve a problem and you can't see what that impairment that you just mentioned, corrosion that's hidden, P&M, it lights the dashboard up for all the modems that are being impacted by that hidden impairment. And so
Okay.
that's where we start to say, hey, here's this great proactive tool, but it works amazingly well as a reactive tool in our set of tools.
Yeah, and there are some really great tools out there, and we don't necessarily want to get into the proactive versus reactive argument today. Um,
We'll save that for another day.
yeah, we'll save that for another day.